Okay, so we briefly kind of looked at this in the last one when we were talking about covalent compounds and how to draw the sharing of electrons. So that dot diagram is called a Lewis dot structure. So we're going to talk about how you create those, and you can use these to represent single atoms as well as molecules. So the elements that are really going to matter for this are, because we are dealing with covalent compounds, so we've got our nonmetals. So you got to remember about hydrogen, all right? And then kind of, some of group 3A over, because boron is a metalloid, which can do covalent bonding, but especially, carbon and silicon and phosphorus, those are all nonmetals. So if you look at this, all you're doing with a Lewis structure is representing the red dots, the valence electrons. All right, so Lewis structure shows valence electrons only. All right, so for example, neon as a Lewis dot diagram would just have those 8 showing. You wouldn't have to have those 2 black ones in the lower shell showing. Okay. If you notice, there is a pattern that goes along with the A number of these rows, right? Everything in 5A has 5 valence electrons. Everything in 6A has 6 valence electrons. All right, so the A number matches the number of valence electrons. So, again, 1A, 1 valence electron. 2A, 3A, 4A, 5A, 6A, 7A, 8A. A number equals the number of valence electrons. Something you want to write down so that you might be asked, draw a Lewis structure for chlorine. You've got to remember, okay, I can go to my periodic table, I can see chlorine's in 7A, it's going to have 7 valence electrons. So, one thing that isn't quite evident looking at these, but you can kind of tell, especially looking at nitrogen, when you add the dots to a Lewis structure, all right, you add 1 dot to each position and double up after all 4 locations. Have at least 1 electron in there. All 4 sides. Okay, so if you think about your symbols, all right, there are top, right, bottom, left. All right, carbon happens to have 4 valence electrons, so that's why there's just 1 on each side. Nitrogen was in group 5A, so to draw that structure, I do 1, 2, 3, 4. All right, and I mean, this is correct. You could also move that electron somewhere else. All right, it's just you only start pairing up once you've put 1 electron on each side. All right, so like oxygen, to get that one set up, it has 6 valence electrons. Do 1, 2, 3, 4, 5, 6. Okay. So, again, you just got to go to your periodic table, look up what column these are in, and that'll tell you how many valence electrons there are. So like hydrogen is in group 1A. 1 valence electron. All right, how about silicon? What group is silicon in? It's right below carbon. So silicon will have 1 valence electron on each side. All right, phosphorus is right below nitrogen in group 5A. So 1, 2, 3, 4, 5. This shouldn't be too difficult as long as you just remember my group A number tells me how many electrons it has, and then I put 1 on each side, and then I can start doubling up. So we can use these Lewis structures to show what a covalent bond will look like, or a molecule. All right, so if you think about this, you've got your carbon. How will the dots, the 4 valence electrons of carbon, look around the C? All right, am I going to have 4 single electrons, 1 at each position, or am I going to have 2 pairs? I hope you said 4 single electrons at each position. All right, and then our hydrogens have 1 electron, so they're going to do something kind of like that. So what I want to do is I want to combine these Lewis diagrams, these Lewis structures, to represent the pairing. All right, so I can take hydrogen and pair with that electron, and then I can take another hydrogen, pair with that electron, and another hydrogen, pair with that electron, and my last hydrogen. All right, so these Lewis dot structures can be done with single elements as well as showing the whole molecule.